Hey guys, welcome to my presentation on addressing transit mode, location bias, and built environment transit mode use research. So this paper was multiple authored and it was published in the Journal of Transport Geography. So primarily coming, understanding the relationship between the built environment, which I'll be calling as BE, and public transit use is crucial for effective urban planning. However, previous studies often fail to account for the location bias of different transit modes, leading to inaccurate comparisons. So the paper aims to address this gap by using innovative sampling methods to compare the BE predictors for different transit mode, ensuring robust and unbiased results. The findings can help urban planners and policymakers design more efficient and targeted transit systems by considering more specific BE factors, ultimately improving public transit ridership and urban mobility. So this study uses data from Melbourne, Australia, focusing on three transit modes. So it has the train, tram, and bus. Two data collection methods were employed: co-located sampling, which estimates ridership for different modes in the same area, and stratified BE sampling, which involves sampling from subcategories with similar built environment characteristics. So coming to the study, they built 20 environment variables and 7 external variables were selected based on comprehensive review of previous literature to represent various aspects of the built environment with robust and reproducible indicators. The outcome variable, transit ridership, was quantified using smart card data as the average weekday boardings at transit facilities. For trams and trains, adjusted average daily boardings for 2018 were used, while for buses, unadjusted average daily touch-ons from August to November 2018 were considered. So to address a non-linear relationship between transit ridership and covariates, the natural logarithm of ridership estimate was used. So here, in coming to the models, regression analysis was used to determine the impact of built environment variables on ridership. The study employed two sampling approaches, so co-located sampling and to control for location specific differences, and stratified BE sampling to generate representative samples. So coming to the analysis approach, it had 6 different steps. So co-located and stratified. So first, the variance inflation factor, the VIF factor, was used to check for collinearity, removing variables with VIF score set greater than 5 in their case. Next, bivariate correlations were between independent variables and transit use were examined, excluding those with correlations less than 0.25. Followed by this, a maximally adjusted regression model was specified for each sample, followed by the definition of parsimonious model. So diagnostic plots using rplot function checked for adherence to statistical assumption, and variable exceeding Cook's distance were considered outliers and were removed from the model. Finally, the model were iterated and removed outliers until no influential outliers were present. So here the linear regression formulation varied for different samples. For the biased and stratified sample, multiple linear regression models were created using RStudio, where predictors with an alpha level greater than 0.25 were removed stepwise. The optimal combination of variables was chosen based on the archaic information criteria, that is the AIC score basically. So followed by this, the co-located sample and adjusted model using multivariate multiple linear regression was necessary due to the interdependence of ridership between modes. So this was confirmed by covariance testing, which showed a strong positive correlation between train and bus ridership and a weakly positive association between tram and bus ridership. Okay, so here we used MANOVA scores, which is basically multiple ANOVA tests, were used to jointly predict the scorings here. And apart from this, coming to the outliers, so these were treated by removing sites causing violation of statistical assumption, including oversampled sites within Melbourne's free tram zone and other outliers identified through diagnostic plots. So this result in the removal of specific outliers across different samples to refine the models better. So I've also told, so in bus tram sample, 4 outliers were removed. And from bus train sample, we can see 6 outliers were removed. From stratified train, 6 outliers, and stratified tram, 1 outlier was removed. So coming to the results and key findings for the co-located sample, multiple linear regression and multivariate multiple linear regression model identified significant association between transit ridership and built environment, as well as socio-demographic variables. The bus tram model explained approximately half the variance in ridership with an adjusted R square value of 0.48 and 0.46 for bus. So common predictors included commercial density, housing diversity, and proportion of full-time employment for residents. So followed by this, in the bus train model, uh, the adjusted R square were 0.63 for train and 0.59 for bus. And common predictors here were the availability of bicycle facilities and pedestrian connectivity. So followed by this, in the stratified sample, service frequency was the strongest predictor for bus and tram ridership, while train ridership was highly influenced by built environment factors with an adjusted R square of 0.68. Common predictors for bus and train included access to employment and car parking at train stations. So coming to the paper's strength and its criticism, basically, the paper's strength included its innovative sampling methods and comprehensive analysis of multiple transit modes. However, potential limitations exist in generalizing the data beyond Melbourne. And this method may be complex to apply to other cities, for example, Chicago or New York. So apart from this, coming to how can I possibly use this in my project? I can use stratified sampling approach to address location biases, use the findings to improve transit planning and forecasting, and consider mode specific built environment factors in transit research and development. And to conclude this paper overall, so the paper addressed the transit mode location bias in built-in environment. So using innovative sampling methods, the study revealed more specified built environment predictors. So the findings underscore the importance of tailored transit planning basically and highlight the effectiveness of stratified sampling. So overall, valuable insights for improving transit planning and forecasting were considered and also proposed in this mode. So possibly I'll be using these methods in my future work of my project. Thank you.